Welcome, everyone. My name is Taurus the Legend. Thank you so much for joining us in our episode 8 of the SAP Garage series. Today, we're going to be covering predict and analyze retail inventory allocation using FedML. We have our presenters today, Cameron Horsanti, business developer at SAP BTP, as well as Jack Seeberger, senior data scientist at SAP BTP Adoption and Advisory. I will now hand it over to Jack and Cameron to take over. Jack?
I'll take over, Taurus. Thank you.
Okay.
I will share my screen. All right. Can you see my screen?
Yes.
Very well. Thank you, everyone, for joining. Today should be a good topic. So without further ado, I'll give it a go. There's something taking place not only around the technology sector, but really businesses around the globe. And what that is companies, medium to large size, are adopting two or more cloud platforms. I think about 75% of medium to large size companies have two or more or using two or more cloud platforms right now. Now, that's a great deal as everyone is moving to the cloud and many companies are adopting this multi-cloud strategy. The benefits include that it helps with them with security, with cost, regulations, but also provides them the flexibility to not be locked into one vendor. So with this multi-cloud strategy approach, many companies are benefiting from it, and many of their infrastructure and architecture is growing. However, it does not come without its costs, especially because a lot of the hyperscalers, they have services available when you have data residing within those native hyperscalers. One of those services include machine learning. For example, if you want to use Azure machine learning, you would have to have data residing within Azure to utilize that service. So our team at SAP discovered this challenge, so to speak, a little while ago and came up with a solution. Because now that many cloud platforms exist, data is also residing in disparate systems. So data is not in one central place. So as a result, this is where federated machine learning library comes into play. It utilizes SAP's data warehouse cloud federation architecture to give you a seamless automated solution for powerful predictions. But let me talk about the challenges for a sec. Well, now that data is residing in multiple places, multiple cloud platforms, there's a lot of data. That brings about the limited access to data, because now, in order to use services within hyperscalers, normally a customer, or if you're a data scientist, you would have to extract data from the sources that you want to use it in the places that you want to. That comes with data replication, duplication, data prepping, and a lot of ETL. That brings about the lengthy time to value, because all of that data prepping, moving around the data, and the duplication process takes time. And it's certainly a headache, I'm sure, for a lot of data scientists. But the other issue is lack of real-time data. Because of all the process that goes with it, there's no seamless way to connect and have live data that you can connect to your hyperscaler services. And with all of that I mentioned, it's a high cost to not only extract data, move data, but also now that you have extra duplicate data to store, you obviously have to pay for that. So there's a high total cost of ownership associated with this new hyperscale multi-cloud strategy. But what are the opportunities, especially with FedML? Well, first I must say or tell you that FedML supports all the major cloud providers. So in this, Azure, Google Cloud, AWS. It was written and developed for these hyperscaler services. With DWC, Data Warehouse Clouds Federation architecture, you can access all of your data, both SAP and non-SAP. So basically, you can couple them together and utilize it for your hyperscaler services. And it's low cost. Why? Because now you're eliminating the need to duplicate and replicate data and seamlessly connect to your multiple sources. And that relieves the headache for many of the data scientists and end users, because it's easy to use, it's simple, and it's really only a few lines of Python code. But how does that work with Data Warehouse Cloud? Well, Data Warehouse Cloud allows you to first, as I mentioned, connect to your multiple cloud platform sources. It really increases the time where you can couple those sources together and really onboard all of your data sets. And it lowers the adoption barrier, because with that architecture, you have a business semantic layer, the abstraction layer, where you can query your results from your multiple sources. And what Data Warehouse Cloud offers is the business content. It's basically a library of templates for your industry specific needs or KPIs, where you can have kind of a starting point. And it's a great way to utilize an adoption-wide, or I should say, enterprise-wide collaboration tool. So this is what the architecture for FedML looks like. If you see on the right side, in the middle, you can see Data Warehouse Cloud as the middle kind of source connecting both your hyperscaler data sources and your SAP data, whether that's from ECC or S/4HANA. You can then couple these data sources, take the library, copy the library, your Jupyter notebook, and run the queries, run the Python code to source, train, and deploy your machine learning models and use the machine learning service within the hyperscaler. That way, if you want to use Azure ML, you don't have to move everything into Azure to utilize Azure ML. You can keep your data as is, where it is, and combine them together to run your machine learning experiments. So in this case, if you're trying to create prediction models, you can simply do that with Data Warehouse Cloud and the FedML library. If you want to go a layer deeper, this is what the architecture for Data Warehouse Cloud looks like. Basically, you're allowed to connect your hyperscaler services, hyperscaler data sets to the connectors of Data Warehouse Cloud and your SAP data. But also what it allows is the modeling within DWC creates a consistent way for you to now expand your modeling into analytics. So now that if you have built your models, you run your predictions, you can now visualize them in a dashboard in SAP Analytics Cloud. We have some links to hyperscaler specific notebooks and some blogs to how you can enable yourself. But let me jump into the mission itself. So in this case, we want to talk about predict and analyze retail inventory allocation using FedML. Now, in this use case, this is for utilizing retail data for inventory reservations. If we look at the architecture here, in this case, we're trying to combine data from Google Cloud and S/4HANA and using Data Warehouse Cloud to be able to run the FedML script to utilize Azure ML, to basically couple everything together for utilizing Azure ML service. Jack will talk about this in a little bit, but essentially you can extend this a little bit even further if you want to using Kima runtime. So with that, I'm going to hand it over to Jack to go over the steps of how you can use this service, use FedML to combine the data and use a machine learning service such as Azure ML.
Great, thanks, Cameron. Let me share my screen. Cool. So yeah, as Cameron was doing the introduction and kind of giving an overview of what FedML is and the Data Warehouse Cloud architecture, I can now kind of jump in and give you kind of a hands-on how this works, how this realizes the kind of entire end-to-end BTP picture, and how you can bring this to life through this Discovery Center mission. So to kind of dive in, as Cameron was saying, this mission is a kind of generalized version of a problem we see in the field a lot. And the basic idea is that you are a retail customer, and this doesn't have to be necessarily with retail data, but this is kind of just an example to make the whole thing kind of a little bit more concrete. But you're a customer that has SAP S/4HANA data in an on-premise system. You have additional hyperscaler data in a third source. In this one, we are kind of highlighting Google Bigquery and Google Cloud Storage. But the cool thing about FedML is because we've kind of enabled this for all the major hyperscalers, you can plug in any other data source into kind of this box where we're highlighting BigQuery for this mission, and combine that with your SAP data. So one of the cool things about this architecture, and one of the things that Cameron kind of highlighted in the slides, is that it kind of really enables that kind of data democratization and data flexibility, because you're no longer tied to having your data sit in one system and having to bring all your data over to one thing to use that together, or bring it one way or the other. Now, by building this semantic layer in Data Warehouse Cloud, you can use that data on any other end source, and you no longer have to go through that complicated ETL process or keep managing that and have all kinds of replication from one system to another and make sure everyone's up to date. Now with this, you can federate that data, make sure it's live, up to date, and the semantic layer is handling all of that on the fly. So what we're going to do is take that data and then in Warehouse Cloud, do some data manipulation and engineering to bring these different sources together, create a new table, and kind of unlock new data value from these different sources, and then use that data on FedML or on Azure with FedML to kind of build, train, and deploy a machine learning model and show how you can get those inferences, and then write those inferences back to your Data Warehouse Cloud and visualize that in SAC. So it's really kind of a full picture of what you can do with the SAP BTP platform. So to kind of show what kind of an end product you can get from that, I'll start off by showing this SAC dashboard. And what this is basically the kind of end picture of writing predictions, combining your data sources, bringing that from Azure to your data warehouse cloud, and being able to visualize that all together. And this is data from Bigquery, your on-prem HANA system, and predictions from Azure, all in one place, able to visualize together, live and on the fly. And this kind of shows what you can do by bringing all this together. You can see you're visualizing your predictions versus your real live sales data versus your inventory versus your kind of full picture, and you're able to drill down, do a whole bunch of different cool things in SAC by enabling this full BTP experience. So how do you do that? So now we can kind of jump into the project, and what I'm going to highlight in kind of some of these steps is what I kind of view as kind of some of the core cool things about this architecture, how you enable the federation, and how you can build that model on Azure. So one of the cool things is it's pretty simple to set up this federation architecture and connect your hyperscaler source or your cloud source together with your data warehouse cloud and your SAP data. So one of the first things I'm kind of go through is how you make the connection from Bigquery to DWC. And the idea is that you have some data in Bigquery, and now I want to use that data in my data warehouse cloud instance. So what I'm going to show here is how that kind of connection looks in your real system. And you can see I have a Bigquery DWC connection. I've connected my Google Bigquery to my data warehouse cloud. And it's pretty easy to do that. All you have to do is hit create, and now you can see all these kind of different right out of the box connections that you can make to your data warehouse cloud. And as you can see, as I was talking about earlier, it doesn't just have to be Bigquery as we're highlighting in this mission, but you can plug in any of these sources into your environment, and now you can have that data that you can combine with SAP data. And to do so, basically, you can just click on this, you put in your credentials, and you're ready to go to start using that data live. So once you've done that, and now that data is available, you can do cool things like combine that data through DWC's platform in a couple of different ways. So what I'm kind of highlighting here is how you can do that with the DWC kind of graphic interface. So what we're doing here, these tables are actually live data from Bigquery. As you can see down here over in the remote table section, these are tables that are actually residing in your Bigquery instance that are now being available in DWC. And what we're doing is we're joining those two tables together to create a new table. And this is all done on the fly with live federation to create this new kind of unified table of our Bigquery data. So then what we do with that is then we take our SAP on-prem data, which is kind of our sales data, our inventory data, that we've created that connection with DWC, and then using the kind of SQL interface of DWC, we're able to combine all this data together and create this kind of new unified table of multiple different data sources. And what you're seeing here is we're combining the SAP data with the GCP data. And then this DWC maintains this live. So every time we need this data, you have the data fresh, combined from the multiple sources. So then what can we do with this data? So now we have this whole new data set that combines different sources that we previously couldn't do. And this kind of allows us to, as data scientists, to unlock new and cool insights from that data. So going back to our mission, what we have done so far is we've connected these different data sources. Now I want to use that data for something. I want to use that to build a machine learning model. And to do that, I want to use Azure. As a data scientist, I'm kind of more familiar with this environment. This is how I want to do it. So previously, I couldn't do it. I couldn't access that data in Azure. I had to replicate that to Azure's native storage, take all the SAP data, move it to one place and make sure it's maintained, do all that. But now, as a data scientist, I can access it easily. And a quick step back, all this code is available in a GitHub on SAP samples. And then we can share, the link is linked in the discovery mission. We can share it later in the chat. But basically, what I'm going to do is set up an Azure notebook and access that with the FedML library. And the FedML library is really cool. It's simple, it's pip installable, one line of code. You're able to start using the FedML abilities. And it's available on all three of the major hyperscaler platforms, Azure, Google Vertex AI, and Amazon SageMaker. So as you would normally do, you do one pip install, and now as a data scientist, I can load all these different modules from the library and start using that to kind of do my training with this kind of new unique data set I created. And what we've done with the library is we've kind of automated some of the kind of complicated steps that you would need to do to create your experiment into a few lines of code. So each of these kind of the ways you do this is unique to the platform, but I'll kind of highlight Azure as is done in this mission. So basically what we're able to do now that we've loaded these different modules in single lines of code, we can set up our environment to do training. So as you can see, one command, we've created our workspace. We've set up our compute and we set up the environment to do our training. So now that's all done. We're a couple lines in and we're ready to start training our model. So now, as then you can see, you just create your training class and we can start training our data or training our model. And all you have to do is run this one line of code, give it the parameters of what you want to do, and then give it your training script. So it's very flexible in how you can move these pieces together. And as you can see here, these are the table names of our data in DWC. So we're not using any of the data that is that we haven't had to move that over to Azure, fetch that data from Azure. We're getting this data live from DWC by just telling it which tables we want to federate to this training job. And in the training script, you can kind of see how this works. So one of the things, the ways that we can get that data is with the DB connection part of the FedML library, which federates your queries and makes that data available for your model to train. And what we've done here is hopefully create kind of a generalized version of kind of a retail model that a customer might want to build. So we've taken data that we think kind of generalizes to a lot of different kind of data types that you might see in a retail situation. Obviously, not every machine learning problem is the same. Nobody's going to have the exact same data. It's not all going to line up nice and neat. But what we're hoping here is to kind of give a launching point for data scientists to create a simple forecasting model with retail data and kind of highlight some features that they could build from that we have seen and used in past model building. So we've created some functions, some kind of basic code of how you might do that train test, and just a kind of simple way to get a machine learning model up and running that then you can adapt to your use case. And maybe you have similar data that you can plug in here and just kind of build a similar model. But as you can see, this kind of takes you through training a model and saving that model. So once this is done and we've done our training, we've told it to what data we want. The training is, we initiate the training job. And what happens is that data is then fetched on the fly live. So as a data scientist, now I'm ensuring that I have the most up-to-date data. I don't have to necessarily worry about wrangling it in this notebook every single time, because that now is handled by DWC, the semantic layer we've created. And it's giving me data from multiple different sources together in a couple lines of code. So now that we've trained our model, we have a trained model. You can deploy that. And the cool thing, what we've done with FedML is that we've enabled you to, you can deploy it to the SAP Schema environment, or you can deploy it native to the hyperscaler that you are using. So the ultimate flexibility as a data scientist is that now this is kind of automated. I just, again, do a couple lines of code. You'll hear me repeat that line a lot. And I'll get an API endpoint that I can now run predictions against. And again, all you have to do is a couple lines of code. So we've made it so that the schema deploy will create your container, register that container, and immediately deploy that to your schema environment, all in a single line of code. All you need is your kube config from your kube environment, and you're off to the races. And then same thing with deploying to the hyperscaler. So say you want to deploy this on Azure, you're training in Vertex AI. Now you just tell it what model you want to deploy, where you want to deploy it, whatever parameters we use. There's a whole bunch of different parameters that you can customize. And again, just like this, you have a API endpoint. There's a lot of code for deploying the schema. You immediately have an endpoint URL that you can use to get predictions. So now that you have an endpoint, it also makes it easy to run predictions. So as you can see here, if you are a data scientist, you just want to access this data from your DWC, we also give that ability with this DB connection. So if you just want to read it into your notebook to do some, say, do some data exploration or do some analysis or build new data frames, you can see here with one line of code, I'm federating this data from this data source or from DWC, and now I have that available in the data frame. And this allows you to, again, use that data from different data sources all at once. And then again, say I want to run a prediction, a single line of code, and I have ran predictions, and I now are getting results from the API endpoint that I just deployed. And then to kind of close the whole end-to-end BTP picture, now I want to bring these predictions back to my data set so that I can get new insights and unlock how the model is performing versus our core data. We allow you with FedML to write that data back to your DWC system. So now I can have my predictions. I can have that with my other data and start doing those cool visualizations that we were talking about earlier. And this is kind of how we create that whole picture of moving data from just your core data to machine learning to visualization. And the cool thing is that with SAP or with SAC, you have a close coupling with DWC that allows you to easily use that with a live connection. So all you can be ensured when you're looking at this analytics dashboard, all your data is up to date. And this is kind of one of the things we walked you through in the mission as well. Because it's SAC is coupled tightly with DWC, there is a simple inbuilt database connection that you can just click that, and immediately your data set's available for analytics. And then, as we were talking about earlier, now you have the ability to create these cool visualizations, these cool dashboards, dive into your results, see and unlock new value from your data and your different data sources that were previously existing in a whole bunch of different locations, and are now in one place that you can do cool new things with. And that's kind of the whole mission. So in this mission, we walk you through all these steps that I showed. The code is available. You can start configuring this. And it's kind of a step-by-step how to enable this architecture for your environment. And as I said, the code's available on GitHub. And then the library is also available on GitHub. So you can explore maybe with different hyperscalers and different use cases. There's a bunch of cool example notebooks in here as well. But yeah, that's kind of the whole picture of how this kind of brings together and how we can unlock new analytics and new machine learning capabilities and new data value through this architecture. And with that, I'll hand it back to Cameron.
Thank you, Jack. Let me share my screen again. Okay, so just to summarize what Jack walked you through, basically the first step is connecting your multiple data sources, whether that's on-prem or cloud. You want to have a central place where you can basically reduce your ETL, but have a central place where all the data is accessible. Now, with the FedML library, you can run the script to combine and couple those data, to build your models, join tables, to then either use it in your native hyperscaler for the machine learning service in the hyperscaler, but also you can use it within Data Warehouse Cloud to extend it even further to visualize your prediction models. In this example, in this use case, retail data, to visualize it in SAC. But the question comes about, well, this is great. This sounds interesting, but maybe this is not something that we can apply to our landscape, to our architecture, or maybe you're not sure how this exactly fits in to your landscape. Well, we here at SAP have a solution for that too. We have a team that Jack and I are part of designers, engineers, and data scientists. What we offer, or what we do, is sit down and discuss with you what, first off, your landscape includes, what are your requirements, and what would you like to see, and what business challenge you would like to solve. And typically through 1 or 2 meetings, we try to qualify, but more importantly, understand how we can help you achieve that. Just get a better understanding of your landscape and your end goal to see if it's possible. Then our team of designers will certainly try to create the outcome that you are looking for and see if that's something to your liking and agree on the scope and the timeline. Then we roll up our sleeves, try to build a custom solution around your specific requirements and your given landscape to see how you can really see this come to fruition. Because given, maybe certain requirements, or depending on the business case, we try to showcase it how you can basically utilize Data Warehouse Cloud, FedML, and if possible, SAC within your own environment and with your specific landscape and specific landscape. So our POC engagements, or what we call proof of concepts, typically take about 4 to 6 weeks. But throughout the journey, we work with you step by step of the way to make sure, one, that we are working with your specific requirements, and we are developing how you want to see this come to fruition. And obviously, at the end, we present the POC, the proof of concept, and what we have built with collaboration with you, given your landscape. There are certain qualification criteria, usually how we typically engage but I would say the first step is, if this is something that's interested or you're interested in, or is interesting for you and for your company, to talk to your representative at SAP. But ultimately, how we qualify to move forward is we would want to just ask for some executive sponsorship. And just to make sure that we are both committed to a POC, is we just agree on a few qualification criteria, which is commitment to a mutually agreed timeline, and just making sure that since it's going to be built custom to you, that we can get access to your relevant data and also the experts that we'll be working with. And once a POC, and this is given, if everything is well and satisfactory, we ask for really an implementation partner to be in place, but that will all be done with your account representatives. But ultimately, our measure of success is a testimonial, a success story. So it's just something that we would like to kind of advertise or promote internally, to say that, you know, it was kind of a good rating of working with you. But that is another resource we have available if this is something of interest to you and you would like to dive further into it and see how it can be applied to your environment. But just kind of summarize everything that we talked about today, with FedML and Data Warehouse Cloud, what we talked about, the limited access to data across cloud platforms. Data Warehouse Cloud connects to all your sources and it allows you to both combine your SAP and non-SAP data. It's simple and seamless for the data scientist and overall the business, because with, as Jack mentioned, with a few lines of code and the pre-built library that our team has created, you can deploy and really generate your prediction models, and then even expand that further with analytics. It's seamless, as I mentioned, because now instead of moving data prepping and trying to transfer over everything to your native hyperscaler, you can instantly access, really streaming your data across platforms for your business requirement, for your machine learning experiments. And it reduces your total cost of ownership because it eliminates the duplication, the replication, and the total cost associated to ETL. Lastly, what I want to do, we have some updates for FedML 2.0. Jack just mentioned this briefly. One is, pip installable and the ability to deploy with Kima. So if you have your phone with you, I know I have mine always with me. You can scan this QR code, and this will take you to a blog post for FedML 2.0, which gives you an overview of the solution, but also the different hyperscalers that you can use it with. So the hyperscaler specific scenarios that you can apply it to and the sample codes are listed in there. You can also find the links to the GitHub as well. The links to the GitHub repositories are in this presentation that will also be shared afterwards. So yeah, I would say if this is something that interests you, I would highly recommend talking with your representatives at SAP, and we are certainly here to help and make you realize your, I would say, data federation and data management goals, and of course, the ability for you to run machine learning experiments, and even with analytics. So with that, I'll hand it back to Toros for any questions.
Sure. Thanks, Jack. Thanks, Cameron. So there's a question from Krish. It says, is it possible to connect to non-SAP cloud-based planning systems?
Yeah, I can answer that. So I'm guessing for analytical planning, but the answer is yes. However, we recommend using SAP Analytics if you're already using Data Warehouse Cloud, because I think what the ability that it provides is with the modeling that you create within DWC, as kind of Jack mentioned, you can use that same modeling within SAC to create your dashboards.
Okay, and I think we have a second question. I don't know if Jack, you've answered this, but from Guy, is DWC required, or is write back to other data stores also possible? Similar for SAC, is that also required?
Yeah, so in order to use the federation architecture, DWC is required. It's kind of the core of how kind of this all works and how you can bring those different data sources together. With SAC, I can believe you can make direct connections through different sources, but DWC is kind of the core way of kind of how, as Cameron was talking about, you create that semantic layer and how you can bring those different data sets together. And so that data is available not only for Analytics Cloud, but for other use cases as well. So basically, you're kind of creating this layer that orchestrates all your kind of data together. But yeah, the core question, in order to do what we highlighted today, you need DWC.
Okay. And then there's one from Sanjeev. Most companies already have enterprise data warehouse capabilities, including AI, ML, analytics. How would these stack up with BTP capabilities?
Yeah, so I mean, I think that's kind of what this use case is exactly targeting, is what we've seen in the field and what we've experienced is that customers have already set up a lot of their AI infrastructure on these hyperscalers. And what we're hoping with this architecture that we enable is that we allow them to still do that and leverage their existing investments, but make it so that they can still use their SSP data without having to go through that complicated process of replicating it to their hyperscaler. And now having to maintain that data in two places, maintain both those costs, kind of go through all of those different processes that you kind of end up when you're having to do this ETL of keeping that data up to date and all that. So now with this architecture, you can access your SAP data, use that and leverage your existing hyperscale infrastructure without having to go through that process, thereby reducing your cost as a customer and allowing your data scientists to focus on the kind of ML and analytics side of it without having to focus on how am I going to maintain all this data. And now you can kind of with this architecture.
Okay, nice. Thanks for that. If you guys have any additional questions for either Jack or Cameron, please do either unmute your line or type your question in the chat. We still have about 20 minutes into the hour, so if you have any questions, please do take advantage of this time. So while you guys are thinking about some of the questions that you may be asking, I just want to let you guys know that we will be starting some on-site events if you're interested. We have 3 events currently planned for those in Canada. The 3 cities that we're going to do is Calgary on September the 13th, Toronto on September the 27th, and Montreal on September the 20th. The Montreal will be September 27th, and Toronto will be September the 20th. I'll include this in an email. So if you guys are interested, there's also an event on October the 5th in New York for those in the New York area, and then there will be another one in Houston for those in the Houston, Dallas area. And then for those in Europe, we will have one event in London for those in London on October the 27th, and those in Barcelona will be it'll be on October the 25th. So if you're interested, these are all BTP focused on-site events covering any topics from RISE, data to value, data warehouse, cloud integration. Our topic experts will be on hand on the site to answer any and all questions. So if you're interested in any of these, please do send me an email and I'll send you the registration link. I don't see any other questions in the chat. Are there any questions before we sign off for the day? Any other questions? Okay. Thank you so much, Jack and Cameron, for your great session. I hope that everybody on the call got their questions answered. Maybe some new questions will pop up in a short time. Thank you, everyone, and have a great morning, afternoon, or evening, wherever you're located. Thank you so much, guys.
Thank you.
Thanks for having us.